In this video, let's discuss the project which made us win our second hackathon. The problem statement which was given was to build an IoT solution for real-time energy monitoring in both commercial and domestic use. So here is the basic block diagram of what we achieved. So we received the data of both current and voltage from the sensors, and to sensors we just transmitted the data to cloud using the Wi-Fi onboard Wi-Fi in ESP32. And we also built a dashboard to just process the data from received from sensor and show the real-time alerts and any insightful data from which the uh, customer or any user can take actions. Here is the hardware circuit of our project. This is the neighboring board, and this is our board. This is current sensor, and this is voltage sensor. And here is a potentiometer to just adjust the timings of the day to show the TOD features. This is the load which we have used in our project, and these are the two bulbs which consumes very less amount of power. Now just look at a small quick demo. This is how the dashboard looks like. First, we have two options. This is home page. We have two options here: home and domestic. That is commercial and domestic. So both have special features, and they are specific for each of them. In home, we don't have the power factor and all, but in commercial, we have power factor, and this is a commercial heart rate. Like if you keep on consuming the same amount of power for 1 hour, the estimated uh, rupees will be this much, and the estimated rupees for home is this much. So the total bill till now is this is all the total amount, which including the rebates and all. And this is the domestic power, right? And this is total energy consumed. We have three gauges: voltage, power, and current. We also have a chart to just plot the real-time power consumption of our home and both industry appliances. This is the power factor. The reason for this very low cost is we have used just two bulbs, but it doesn't consume much energy. So the cost is lesser than 1 rupee. So to mention what features we added, all meters just monitors their voltage and current readings and the power, and just shows you that. But what's special in this meter is it gives various alerts, like alert for over voltage, under voltage, and alert for usage beyond the threshold limit which is set by user only, and real time cost monitoring. This includes both rebate and penalties also, and also low power factors for alerts for commercial purposes. We have specially curated features for both commercial and domestic purposes, and also the TOD optimization, tariff of the day. Basically, to promote the usage in off-peak hours, the tariff of the day is used. So during off-peak hours, we get a rebate of -1 rupees or something like that. So we also added this feature also, and this feature is very special for us because to do this, we have used a neighboring smart meter also. So when there is a power outage in our house, our smart meter just communicates with the other smart meters neighboring us, and by communicating the power status of all neighbors, we decide whether the power outage is only in our house or it's over the area. And we also have an user-friendly dashboard which I'll be showing you. So to understand the basic workflow, first we collect the data from the sensor, and we process it in on ESP32. From there, we have used a cloud-based MQTT broker, that is Hivemq. From there, we have built dashboard using our Node-RED. We have subscribed to the topics uh, using MQTT protocol, which will be transmitted from ESP32 itself. And based on the subscribed topics, we get the data and we just reflect it on our dashboard by doing some other processes and all. And we also give alerts, which I have already mentioned you. And we have used Ngrok for to make it online, to make the dashboard online. So now let's look at the software overview. We have used two libraries, that is Emon and Wi-Fi, basically the main things. And math and CMath is also required. And these are the things we have initialized many libraries, many variables which are essential. And these are the things which are set by us manually. So the penalty and rebate price things. We have also given us calibration factors, which could be done through trial and error methods, and also our Wi-Fi credentials and Hivemq broker credentials also, which is essential to just do a proper handshake using MQTT. So first we'll be just connecting to the Wi-Fi using the set Wi-Fi function. So this function is just a callback function, is just used to handle the incoming MQTT messages. So any message, if any message is arrived on subscribe topic, this function will be called, and all message will be stored here in this message, and its size is of 50. So when the message arrives, this function gets called and it will be stored here. And we also have a conditional statement here, if else statement. So if the neighbor has power, then neighbor power will be true. If neighbor doesn't have power, then it will be false based on the message received from the neighboring meters. And we also have a reconnect function, which is used to reconnect to the MQTT broker if it is get disconnected. And this function is just used to calculate the power factor. So first we'll be using Emon library to just read the uh, data from the sensor pin and all, and we'll get the current and voltage values. This just creates a MQTT handshake, and we are using MQTT TLS thing. So to just make sure that we don't give any certificates explicitly, so we just use set in secure. This is a loop function where constantly if our client gets disconnected, we just try to reconnect them. And here we are calculating the VRMS of our voltage, I mean the voltage RMS value, and we'll be printing it simultaneously. If the voltage is very less, then our power status will be false. And this 30 is just for a tweaking purpose, and we have given some threshold because our sensors are low cost, so it gives some random noise values. So this is very much required. And this thing is to check if my neighbor has power, and if I don't have power, then there must be any fault, so I need to call a technician. So we'll be just comparing with the neighbor boards. If they also doesn't have power, and if I also doesn't have power, then there's no problem in that. So these are the functions just to calculate the IRMS, then power, and this is also for current. So here we have a TOD thing, like we have just used a potentiometer to just adjust the timings in a 24-hour format. So this was done just for a demonstration purpose. Like you can't wait for 24 hours to wait to get 10 o'clock or off peak hour. So by using potentiometer, we can just instantaneously show the varying of TOD feature. This whole thing is about TOD itself. So coming to the final part, it is SNPrintf. We have just formatted the VRMS value into the size of 50 by using SNPrintf, which eventually gets stored on voltage value. Then we'll be publishing it to the 8 topics from port 1 to port 8. We have created 8 topics, and each topic will be transmitting each data, and we'll be subscribing it on Node-RED. And all processing is done only on ESP32, nothing is done on the Node-RED thing. This is just to uh, avoid the or offload the things. to make the process smoother. Now coming to the neighboring meter, and this is the neighboring meter code. Everything is same. Just there is a button. If button is pressed, then we will have power. If button is removed, then we don't have power. That's all this code, and it keeps constantly sending the data of power present power status to the cloud. We have created a separate topic for this, and we have subscribed for the same on Node-RED. So this was all about the code. This is the overview of our Node-RED platform. We have created many different flows, and I'll be explaining one by one. And so in the first flow, what we have done is we have just subscribed to three topics, that is part 1, part 2, part 3, and we have given the created a gauges to just show these gauges are for both domestic and commercial purposes. So these gauges will show the current and voltage readings and power readings instantaneously. And also we have given a function, so if there is under voltage, just it shows a notification. So coming to the next topic. So in this topic we have just given we have subscribed to topic 5, and which shows the domestic hour rate. And also this part 8 is another topic which gives a total bill. So if the total bill exceeds the set limit, we have also pushed another notification here. And for energy consumed also, the total energy consumed, we have subscribed to that topic, that is part 7. If the energy consumed is greater than that threshold set by us, and it pushes a notification again. So this is the thing which we did for our home page. On pressing the commercial button, you will be redirected to the commercial page. If you are pressing a domestic button, you will be redirected to the domestic page. We have achieved this using the UI control thing. So coming to the last thing is the commercial R rate and the power factor. So these are the topics which we have subscribed, that is part 6 and part 4. Again, if the power factor is lesser than the threshold, the notification will be pushed, and this is just a simple conversion thing.